StudyKwik, we make aviation concepts simple, clear, and engaging. Today, we're diving into drag, one of the four main forces acting on an aircraft. Aircraft generate thrust to overcome drag, but drag is always there, resisting motion through the air. It acts parallel and in the same direction as the relative airflow, constantly trying to slow the aircraft down. If thrust stops, drag quickly takes over, and the aircraft begins to decelerate. Total drag is made up of two main components: induced drag, directly related to lift production. Parasite drag, not connected to lift generation. Induced drag occurs whenever a wing produces lift. At high angles of attack, the pressure difference between the wing's upper and lower surfaces becomes greater. High-pressure air beneath the wing curls around the wingtip toward the low-pressure air above, creating swirling wingtip vortices. These vortices deflect the airflow downward and tilt the lift vector slightly backward, creating extra drag. This is why aircraft with winglets often have better efficiency. Winglets help reduce vortex strength. Parasite drag has three distinct types: form drag, caused by airflow separating from the surface, creating turbulence and pressure drag. Streamlining shapes reduces form drag, while blunt or exposed parts increase it. Skin friction drag, the microscopic roughness on a surface that causes air molecules to stick and slow down. Smooth, polished surfaces maintain laminar flow, while dirt, ice, or rivet heads disturb airflow and increase drag. Interference drag, caused where different airflows meet, like at wing fuselage junctions or strut attachments. Careful aerodynamic design can reduce it significantly. If we plot drag versus airspeed, we see induced drag dominates at low speeds, especially near stall, when the aircraft must fly at high angles of attack to maintain lift. Parasite drag rises sharply with speed. Doubling your speed quadruples parasite drag. The point where the two curves meet represents minimum total drag speed, important for best flight performance, endurance, and fuel efficiency. At StudyKwik, our mission is to help pilots and learners master these concepts with absolute clarity. We believe aviation knowledge should be accessible to everyone, from aspiring student pilots to seasoned professionals brushing up their skills. Your support keeps this mission alive. Every contribution allows us to create more educational videos, interactive tools, and learning materials for the global aviation community. If you've gained value today, please consider donating generously to keep our educational wings strong. Simply scan the barcode at the end of this video to be part of our journey. Your generosity is the lift that keeps StudyKwik in the air, helping us bring aviation learning to every corner of the world.